All right, class. So let's take a look at our last example, which is on energy, and really this is on energy and cost. All right, so the question states, calculate the power delivered if the voltage equals 120 volts and the current supply is 50 amps. Also, if the power company charges you 10 cents per kilowatt hour, how much would you pay if the load ran for 24 hours? All right, so there's two equation that you can use to calculate the energy, which is this is one, which is energy equals power times time. And for this case right here, we're using hours to represent time. All right, the next one will be this one over here, which is power times times divided by 1,000. So essentially what this one's doing is just converting the watt hours to kilowatt hours. And me personally, I prefer to just use this one right here. And just after I calculate my watt hours, if I want to convert it to kilowatt hours, I'll just move my decimal place 3 places to the left in order to convert it to kilowatt hours. So this formula over here is doing the same thing, except that it's just doing it all in one step. So whichever one's your preference, play around with both of them, see whichever one you like to use the most. But the one I tend to refer to the most is this one right here, and I'll just convert it to kilowatt hours afterwards. All right, so the first things first, we need to calculate the power. All right, so we know from our last example, power equals V times I. And so we have our voltage, which is 120 volts. And we know our current, which is 50 amps. And so we plug that into our calculator. We get 120 times 50 equals 6 kilowatts. All right. And so now, if we want to calculate the energy is going to equal your power times your time. And so now all you have to do is just plug in your power, which is already in kilowatt hours. I mean, it's already in kilowatts, rather. So 6 kilowatts times your time. So we're saying that this load is running for 24 hours. And so if we multiply this times 24, we get 144 kilowatt hours. So let me take a step back and show you what I mean. So if power was not already, if I didn't calculate power to be in kilowatt hours, this would equal 6,000 watts. And so you can use the same equation right here. So you say E equals 6,000 watts times your time, which is 24. And you would equal 144,000 watt hours. And so at this point, if this was what I calculated, all I would do is just move my decimal place 3 places to the left and convert it to 144 kilowatt hours. All right. So let's move on with this example. All right, so we got the first part. Calculate the energy. All right, so now they want to know how much it would cost to run this load for 24 hours. So most utility company, they'll have this rate where it's given in cents per kilowatt hour. And so in this particular case, it's 10 cents per kilowatt hour. So 10 cents per kilowatt hour. So that's the same thing as saying 0.10 dollars per kilowatt hour. All right, so if we use that conversion rate and plug it in, so we already have our kilowatt hours. All we just need to do is just convert it to dollars per kilowatt hour. So we got cost equals 144 kilowatt hours times your dollars per kilowatt hours. And of course, your kilowatt hours cancel out. And so this equals $14.4 that it would take to run this load for 24 hours. All right, so that's it for that example. If you have any questions, feel free to reach out to me.